Yes, hello, good afternoon to everybody attending this webinar. First of all, thank you for your attention. And my name is Javier Palomino. I thought that you would like to see a couple of examples of how to test a current transformer using the Raptor system. You remember we were going to use the Raptor system to check current transformer. In this particular case, we are testing protection current transformer. I will show you the setup. Okay, this is the transformer we are going to test. This is a protection transformer. This is the current circuit. Okay, the injection circuit that we are going to close for the ratio testing. So we are going to inject primary current as much as similar to the nominal current as possible. I think in this case we are going to do the to use the nominal current with no problem, even with this small setup with the Raptor. And also you have here the connections that we will use to measure the secondary current output. Okay, so we are measuring the secondary current output, and I have also made additional connections for voltage measurements. Okay, and also for the second test that we are going to do, which is the magnetization test or knee point measurement. Okay, so these are the secondary connections. I will show you now what are the connections in the Raptor's diagrams. Okay, in the template diagram, so you can see the schematic drawing of these connections, possibly more clearly than you can see right now. Okay, so the first thing I am going to do is to complete the current injection circuit. Okay, by just closing this terminal, so the circuit goes inside the Raptor and comes out through the protection transformer. Okay, so we will get the injection current through this cable here, and we will get the measurements from the secondary here. I'm going to change the camera so you can see what I'm doing on the back side of the unit. This is the auxiliary output from the Raptor. Okay, so in the Raptor you can use the main output only for current. Okay, only for current injection up to 15,000 ampere here. Okay, or the auxiliary output here. I must tell you, I must emphasize the or. You cannot use both outputs at the same time. Okay, so and also the Raptor will not detect if any receiver or any element is connected to these outputs. So you must make sure that the auxiliary output is open when you are using the main output, and vice versa. Okay, so the main output should be open if you are using the auxiliary. Don't worry, there won't be any damage to the unit if you use both. Okay, the only problem is that measurements will not be reliable. Okay, the unit will not be able to measure the outputs and stabilize properly and make the output correspond to the value that you have selected in the command unit. Okay, so in this particular case, as we are going to check the ratio in this transformer, we are going to use only the main output. So these outputs should be disconnected from any receiver. In this particular example, in this particular practice, we are only using a very simple version of the Raptor. Okay, the minimum Raptor configuration, which is the master unit, the Raptor C-05, with the commander and all the accessories that come with the unit. okay, connections, cables, and that's it. So for the ratio measurement, as I told you, we are going to use the main output here, okay, main current output, and we are going to use the ammeter, which is on the left side of the unit, okay, the ammeter, to evaluate, to measure the secondary output while we are injecting known value for the primary, okay. So, and you see in this part here, this is the auxiliary output that I mentioned to you before. It is on the right side of the unit, and we shouldn't use it while we are using the main output here, okay. This is the schematic connections diagram that you will get from the current transformer template when you select it in the command, okay, in the command unit. I will switch now to the visualization of the command unit on the screen, so you can see all the entire operation of this unit. Okay, so you can see now a representation, a live representation of the command unit of my Raptor. So, well, first of all, sorry, I'm going to switch to English language. As you see, I am operating the command unit from the computer. Okay, so you can do it at any time if you wish to show the operation to a group of people. You can do it very easily. So we go to configuration, select language, and go to English. Okay, so we are back to the last template that I was using. I was just checking the point for you, but I'm going to select the current transformer template to perform the ratio measurement. Okay, so let's go to the menu again, go back to the templates palette, okay, the templates menu, the list of templates, and you can see all the factory setting templates here. Okay, these are all the templates that come with your Raptor when you buy it. So you can see also at the end of the list, you can see some different templates. Okay, these are in blue color. This means that a user made customized templates and saved it in the commander for future use. Okay, so you can not only use the templates as they come from factory, but you can also make copies and modify any aspect of any factory template and create your own. So for this particular example, we are going to use the current transformer template, which is here, okay, and what we get is a template with 8 seconds countdown here. You see, okay, 8 seconds countdown, which means that by default the test will take 8 seconds to do the measurement. Okay, this can be modified, no problem. I mean, I can go inside the timer settings and modify this. Okay, I can set a smaller or shorter value, or larger or longer time for testing. Okay, this countdown will automatically stop the test when the time has been exhausted. Okay, so let's leave it in 8 seconds as default. Okay, if you see, these are the timer settings, so I can select chronometer, in which setting the timer will just measure the time of the test, or I can select countdown, in which case the timer will control the duration of the test. Okay, which is the case. So you also can see here in this template some meters. Okay, these are hardware meters. These meters in the top section of the template correspond to physical meters in the Raptor unit. Okay, so this is the ammeter input. This is the voltmeter input. This is a physical measurement of the degrees or the phase angle between the output current and the current measured in the ammeter. Okay, and this is also a phase angle measurement between this voltage input and this current input. Okay, these meters will be used if we complete this test with the Barden measurement. In this case, we don't have any Barden connected to the transformer, so we are not going to measure any voltage at the secondary output. Okay. And also these meters here, which are the calculated meters in the central section of the template. Okay, all the templates have the same layout. Okay, topmost section for hardware meters, central section for calculated meters, which are normally the results of the test. In this particular template, we will get apparent power, which is the product between the measured voltage and the measured current in the secondary. In this case, we are not measuring any voltage because we don't have any voltage drop at the secondary. Okay, we don't have any Barden connected. This is the phi cosine, the cosine of phi angle. We don't have any in this case, also because we don't have any Barden. Any angle will be no angle will be produced at the output of the secondary. Okay, we have the impedance, which is the product between also calculated from the product between voltage input and output current. Okay, and this is the ratio itself. Okay, the ratio between the injected current and the measured current in the secondary, which is ammeter 1. Okay, this meter, okay, will be used to evaluate this ratio here. And we will have a second page of results, which is the error percentage. Okay, I mean, the test will also display here the difference between the theoretical ratio in the transformer and the actually measured ratio. So how is it possible? How does the Raptor know which is a theoretical ratio in the transformer? It is very easy. You just need to go to options, enter the meters section, okay, and in the in the calculated meter section, you just navigate until you find this meter, the ratio meter. Okay, so in this ratio meter, you can see there are tools that allow you to configure and to enter the theoretical ratio of this transformer. Okay, I think it's 500 to 1. Let me check. Yes, I think this is 500 to 1, so let's enter 500 here. Okay. the options. You can also see the connection diagram as I showed you. Okay, this is exactly the same diagram I displayed on the presentation. So these are the connections that we are going to use. In this case, we don't have connections for the Barden. Okay, so in the screen you could see, let me show you. You see there is no Barden connection here, so this is a much simpler connection scheme. So you have the primary injection circuit, which is this one, okay, and this is the secondary measurement circuit, which is represented here. All right. But going back to the commander, the diagram shown by the template. Okay, this is a more generic diagram. Okay, so it's valid also for the cases that you are connecting a Barden, a load at the output of the transformer, and you also do the voltage connections to evaluate the Barden in terms of value and phase angle, so you also get a power factor and so on. Okay, so going to the test, I'm going to use the nominal current, so I adjust 500 ampere. Okay, in the commander, enable the output and press on. Okay, so I'm pressing on, and you start getting readings here. Okay, so after the 8 seconds time has elapsed, the test is automatically stopped, and you get this value here. Okay, which is the ratio. Okay, this is not the ratio. Okay, this is the representation or the equation between the injected current and the measured current in the secondary. So we have injected 500 and we have measured 1.01 ampere in the secondary. Okay, so these are the actual measurements. And if I click on this section, just click or touch with your finger, you go to a second page. You see this is the second of 2 pages of results. Okay, so you get error percentage of 0.50. Okay, so this transformer is evaluated to 0.50%. If I click again, I go back to the first page of results. Okay, so this is the measurement we got. Okay, this is the impedance measured at the output at the secondary. Okay, this is not actual impedance of any Barden because I'm not using any Barden connected at the output. Okay, so yeah, this is a power factor. Okay, in this case, you see I have inverted polarity. So this is also a very simple way to check polarity in the transformer. Okay, so these are the results. Of course, I should save these results, okay, in memory, so I will be able to download them and to prepare a report in the computer. But you see, the save button is not enabled. This is very simple. The reason for this is because I didn't open a results container. Okay, I need to open a results container before I can press the save button at the end of every test. Okay, I just go to the reports section. Okay, and just select an existing report and open it. Okay, for example, you remember the last report we used in the past webinar. We can open this one. Okay, we can open this one and continue adding results to these reports, or we can create a new report, which is just a new container for new tests. Webinar. Okay. So I have created this new report. This is empty. Okay. This is empty, so I can start adding. You see, now I have the save button enabled. Okay, so just let's go repeat the test. Enable the output and press on again. Okay, now I can save the results. Okay, so I save the results. When you press the save button, you get save test. You also get delete the last saved test or save test with a description. Okay, you can use any of these options here. You just press here, the results will be added to the test with just a timestamp and the name of the template that you are using. Okay. If you press here, the last saved test will be removed permanently from memory and replaced by this test. Okay, and if you click here, you will be given the option to add some description before the results are saved into the report. Okay, so we can click here and write a description. Transformer ratio measurement. Okay, so I just click OK and that's it. Okay, so next example, knee point saturation measurement. Okay, on the same transformer we are going to evaluate the saturation voltage. In this case we are not going to use the main current output. Okay, because we are not going to use primary current for this test. We are going to use secondary current. We will use the auxiliary output to apply voltage in the secondary of the transformer. Okay, you see that the primary is open. There is nothing connected to the primary in the transformer. No circuit, no receiver, nothing. Okay, so it's open, and we will use only the secondary, which will exhibit a large impedance, okay, because the primary is open. So I will be able to apply voltage here, and very little current will develop inside the secondary. Okay, very little current, but still the current will be proportional to the voltage applied until the saturation point is reached. When the saturation voltage is reached, the current in the secondary will start evolving in a different way. So it will be detected by the Raptor and it will be determined as the saturation voltage. Okay, let's go back here. So we will be using the auxiliary output on the right side of the unit, which is here. Okay, and we'll inject voltage in the secondary of the transformer while the Raptor is measuring the current flowing in the secondary. Okay, so going back to the diagram, you will see that we will be applying voltage, okay, sorry, to the secondary of the transformer, but you see this side of the voltage injection is going through the ammeter and completing the voltage circuit here. Okay, in this way we will be able to evaluate the current flowing across the secondary of the transformer. Okay, and we will also be monitoring the voltage drop in the secondary taps of the transformer using the voltage meter in the Raptor. Okay, so we will use an output connection and two input connections, the ammeter and the voltmeter here. Okay, so what about the voltage, the saturation voltage? Normally you normally you know what's the expected saturation voltage in the transformer, but if you don't know, you can always calculate it approximately. Okay, you can always calculate it using this formula here that combines the accuracy class of the transformer, whether it is a protection transformer or a measurement transformer. Okay, it combines this factor here. It combines also the nominal current in the secondary, okay, as per the expression of the ratio. Okay, in the ratio expression, you take the secondary and you put it here in the equation. It also combines the resistance of the current transformer. If you don't know, you should set it. You should start with a 0 value here. Okay. In this particular case, we know the resistance of this transformer, and it is. Let me check. This is something like 1.175 ohm. Okay, so we can set this value here and then calculate this ratio here, which is the nominal primary, okay, and the nominal secondary squared. So from this simple equation, you can approximate the expected value for saturation voltage. In this particular transformer that we are using in this example, the voltage is evaluated by this formula as around the 30 volts. Okay, so coming back to the Raptor commander, okay, we see here the last screen from the previous test, and we are going to navigate and select from the menu a function that's named CT magnetization. Okay, this is the way this function is cataloged in the Raptor menu. Okay, the knee point evaluation is named CT magnetization, and this is a function you see as a different thing of templates. Templates are just arrangements of meters and results, but functions are a little bit more complex things. Okay, functions do something automatically. In this particular case, the CT magnetization function will automatically ramp the voltage across the secondary while the current is being measured. Okay, so if we activate the CT magnetization, we get kind of a template, but it's not just a template. Okay, you get meters here, results sections here, but there is also some automatic functions in behind. In the options section of this function, you can also see the connection diagram, as I showed you in the presentation. Okay, so you see that we are not going to use the main current output, but instead we are going to use the secondary, the auxiliary output from the Raptor to inject voltage in the secondary while we monitor the current and the voltage drop. Okay, so
you see in the CT magnetization function here, which is the one that I have just loaded, there are two parameters that I have to enter. This is the maximum current allowed in the secondary. Okay, this is a way to safeguard your transformer. Okay, for example, yesterday I found a transformer that had a short circuit inside. If there wasn't a limit in this parameter here, this short circuit inside the transformer could have resulted in some smoke or something similar, okay, because this transformer was damaged, okay, in the secondary. This had a problem with the isolation, okay, so it had a short circuit, but thankfully this function has a current limitation here. So normally you will get very low current in secondary, okay, so just 1 or 2 amperes maximum would be okay. Okay, in this case I will set it to 1 ampere. Okay, and here you are expected to enter the expected value for the saturation voltage. Okay, in this particular transformer, I think it's around 30. So let's go to 30. Okay, so enable and start. So you see, okay, the time is just elapsing, and you can see what's the current in secondary. Okay, this is just a few milliampere, okay, because the impedance is very high. And this is the voltage ramping. You see the voltage ramping progressively until the maximum is reached. If the function reaches the maximum and there is no knee point found, you will be said that no knee point was found. In this particular case, we have found a knee point at 28.7 volts. Now the system is automatically taking power off the secondary, okay, for safety, and just finished. So we can see the graph, okay, with the saturation point here in this transformer. Okay, 29 for example, and start. Okay, so same point has been found here. Okay, we can see the graph again. Okay, this is saturation point here. Okay, if I go a little bit beyond the 30, I will take this point to the center of the graphic. Okay, so possibly I prefer a wider representation of the ramp by using, for example, 32 volts. Start again. Okay, so this is the graph now. Okay, you see, now we got the dot. I mean the plot of the saturation voltage more centered in the graphic. Okay, you shouldn't go too much farther from the actual value. For example, 50. Okay, you possibly will not be able to obtain a result because the resolution will drop a lot. Okay, the resolution of the search of this function. So it is important that you maintain the parameter, okay, the expected maximum voltage as close to the actual saturation voltage as possible. All right. But anyway, if we, as you have seen, if we go a little bit further, we will get a clearer, more clear graph of the current evolution closer to the point, okay, to the saturation voltage point, which is here. So again, we just save the results. Okay, just save the test, and that's it. And we get the results for the two tests. If we go to the menu again, navigate to reports, okay, I can see, you see the report which is currently open is the one I created for this particular webinar, so I can view it. And you see every test in the report will have automatically the template name. Okay, so the first test I saved in this report took the name of city, which is the name of the template that I used to evaluate the ratio of the transformer. Okay, so these are the data saved from this test. Okay, the description that I wrote, etc. Of course, this is a very very brief expression of the results, just for the sake of the size of this small screen. Obviously, all these results and data are better represented on the computer when you upload these results to the computer. Okay, you can navigate page by page, okay, through the report by just clicking on these arrows here. Okay, so this is the first test. This is the second test, CT magnetization. Okay, we can go back and forth. All right. So this is it. So please let me know your questions if you have any.
Hello, Javier. Regarding the testing for the seat, for the point, how can we know for the how can we know what the input of the maximum voltage?
Yeah. Okay. So let's go back to the formula. Okay.
Yes.
Okay. Here you can see the formula again. Okay, and you see
Yes.
how we combine the data from the nameplate of the transformer into the formula. Okay, so you can see that the expected saturation voltage, which is this value here, will be calculated from this factor, which is this number or this number. Okay, in the case of a protection transformer, okay, you see this is the typical notation in a protection transformer: 5P10, 5P10. Okay.
Yes.
And this is the typical notation in a measurement transformer, which is 0.57 M7. Okay, so you have to use the accuracy factor, which is this value here, in this element of the formula as A of n. Okay, so then we go and enter the secondary nominal in the transformer. Okay, in this particular case,
secondary.
Yeah, the nominal
Yes,
transformer is 1 ampere. Okay, So I just enter 1 ampere here. So I need to multiply. I will have to multiply. In this particular case, I am multiplying 10 times 1. So I get 10 in this section of the formula. Okay. So
7
for this
times
particular transformer is 10
1.
here.
Where's the resistance?
Now I have to resolve this part of the equation, entering the transformer's resistance here. Okay, in this particular case, as I showed you, it is 1.17. Okay, so
Yes.
I have to enter 1.17 here, and also I have to resolve this quotation here, okay, by dividing the nominal in the primary, which is 500. Okay,
Oh, yes.
nominal in the primary is 500. Okay, sorry. No. This is the power. Okay, sorry. No. This is not the primary nominal. This is the
Not the
power
city.
of the transformer. Okay, this is the volt ampere value. Okay, volt ampere value here. Okay,
1.
and dividing by the square of
Secondary current.
secondary nominal.
Yes.
Secondary nominal. So which is 1. So I get 1 divided by 1, which is 1.
1. 1 plus.
Plus the resistance, which is 1.17, which gives me 2.17. Okay, and then I multiply this
Okay, 1.
by 2.
1.
By 1, I had 1 here. I had
Yes.
10. Sorry, by 20. No, by 10. 10.
10.
So I have 2.17 by 10, which is
Times 10.
21 something.
Yes, times 10.
Okay, so I could start just
21.7.
entering 21 something on the equation. Okay, I could start by
21.7.
27.
21.7.
Yes, 21.7. That's correct. So I go to the Raptor here. Okay, So we can go here. Okay, and start by entering 22, for example. Okay, I don't have decimals here. Okay,
So,
I have to use.
So it means if for the 21.7, we round up to 22 because we have no decimal.
We don't have any decimals, but remember that
Yes.
this is a limit. Okay, this is the maximum voltage for the automatic function.
Okay.
The function will just stop here. Okay, so the accuracy of this value is not really important. Okay, this is just
Yes.
the point where the ramp will stop.
Okay.
So the actual important value is the value that the function will find. In this case, if I enter 22, the function will not find any value because it will come short of the search. Okay,
Yes.
it will stop before the actual saturation voltage is found. But this can happen to you. I mean, the formula that we have seen is just an approximation. Okay,
Yes.
it is just a reference point. You know from this formula you know that your value will be around 22. Okay, but for sure it will be somewhere between 20 and 30. Okay, it is the most common case. So if you don't find a saturation voltage in the range of 0 to 22, you should do a big step. Okay, for example, going directly to 30 and try again. Okay,
Yes.
just enable and try.
Okay. So it means you must do the trial and error when you get for the saturation voltage?
Yes, normally it takes 2 or 3 tests.
Yes.
Okay, it is, and unless you are testing a transformer that you have tested in the past, okay, and you know exactly the value of the voltage that you got in the past, okay, unless you have this case, you will possibly do 2 or 3 tries every time, okay,
Okay.
even though you find a point. Okay, like in this case, for example, you see I have entered 30 and I have got 27.7. If I go to the graph, okay, this graph is fantastic. It's very good. Okay, so I don't need to
Yes.
do any other try. This graph is perfect to hand to a customer or whatever. Okay, so
Okay.
you don't need to try again or whatever. But
Yes.
if
But
you,
if you need
yeah,
to see the more on exactly where is that point, the knee point, where it's located now at the center, so we can move at least uh, two ball, I think 32 to two
yes,
voltage.
yes. You have to move in the range. I mean, at both sides of the theoretical value. Okay. Of course,
Okay.
if you don't find a voltage with the theoretical value from the formula, okay, you need to increase the maximum. Okay, because the function has scanned all the section between 0 and that maximum, and it has found nothing. Okay, so you should increase. Of course, you have to be sure that you are using the formula properly. I mean,
Yes.
if the correct expected value from a properly used formula is 20, and sorry, it's 20 or 30, like this case, and you enter 50, you can you can find that there is no that the function doesn't find any value in that extremely wide range. This is because
Yes.
the test points that the formula that the function is using are too much distant to each other. You know, I mean, the
Yes.
formula will not have sufficient resolution to locate the actual value, which is hidden very far below the excess that you have entered. So if you calculate theoretical 20, for example, and you enter 50, uh, chances are that the function will not find any saturation voltage, even though the 20 is well inside the range. Okay, because you are extending the range too much. So if you extend the search range too much, chances are that the function will not be able to distinguish saturation voltage. So you have to always do your best to start searching as close as the theoretical value as possible.
Yes.
Have you got me?
Yes.
Okay, so this is a question of resolution, because the function, okay, the automatic function in the Raptor will use a fixed number of test points. So if you extend the range too much, the test points will be too much extended, okay, too much elongated. So chances are that the actual voltage will fall inside two consecutive values and nothing will be found. Okay.
Yes. It's okay for us.